Okay, good morning students. Once again I am very pleased to present you today a very informative chapter, that is electrochemistry, because I have already explained you in previous class redox reaction. Tell me anybody, what is electrochemistry? Electrochemistry is what actually? The branch of chemistry which deals with the study of conversion of chemical energy into what energy? Electrical energy, and its vice versa. So all the reactions associated in electrochemistry is redox reaction, in which oxidation and reduction go side by side. For example, if I take Zn plus copper sulfate aqueous, then what is there now? It is a displacement reaction. In electrochemical series, the reduction potential of zinc is lesser than the copper, so zinc can displace the copper. Zinc is more reactive than the copper, so in zinc pot we should not keep copper sulfate solution, because of redox reaction takes place and cracking can appear on the wall of the zinc pot. So here my purpose is to make you well aware about which is oxidized and which is the reduced, because electrochemistry is very much based on the concept of redox reaction. Dear students, ZnSO4 aqueous aqueous plus copper solid. Since it is the zinc is the zero state and zinc here is the +2. What is this? Anybody tell me? 0 to +2 increase in oxidation number. You know it very well. It is, what is this? Oxidation. And copper here 2 positive and copper 0. That means decrease in positive charge. Well, you know it is the reduction. Those substances which undergo oxidation act as what agent? Reducing agent. And those undergo reduction acts as what agent? Oxidizing agent. Many more reactions we have done in previous class, but here the first part is, after that, what is electrolysis? The process of disintegration of, you know it very well, disintegration of, the process of decomposition, better to write, decomposition of electrolyte in electric field, applied in electric field, called, what is that? Electrolysis. See, in this process, here you take 2 electrodes, negative pole is the cathode and positive pole is, what is that? Anode. So at cathode, positive part is going to be deposited, and at anode, negative part is going to be deposited. Their negative part is called anion and positive part is called, what is that? Cation. That is the process of, what is that? Electrolysis. Electrolysis. That takes place in the single beaker or container. So always you keep in mind, at anode, what is going to be a oxidation, and at cathode, always you remember, what is that? A reduction. So let us consider some few examples here, right? Molten NaCN undergo electrolysis to form Na positive plus Cl negative. This is deposited at cathode and this is deposited at what? Anode. At cathode, what is going to take place? Cathode, reduction takes place. You have added 1 electron, sodium in solid state, and here, since anode oxidation takes place, so Cl2 half time and 1 electron is lost here. So that is, this side it is what? Oxidation and this side, what is this? Reduction. The way you can write here, process of electrolysis. But once I change the medium, if I put sodium chloride in aqueous solution, then the answer is going to be changed. See, aqueous solution of NaCl undergo electrolysis, Na positive aqueous, chloride ion aqueous. Since it is the aqueous solution, therefore water also taking part in electrolysis, because water is an electrolyte. So water is in the liquid state, but once they are mixed with this, it forms aqueous state and OH negative. Dear students, here these two at the cathode and these two particles at the anode. So at cathode, here we have to compare the reduction potential. Keep in mind, because in electrochemical series, lithium, potassium, sodium, magnesium, aluminum, then iron, then zinc, copper, mercury, Ag, Au, and last with fluorine. It's all right now. So at cathode there is the competition between sodium ion and hydrogen ion. Reduction potential of hydrogen ion is 0 because it is a standard electrode potential SHE, and sodium is the negative. So since hydrogen ion had more reduction potential value as compared to the sodium ion, that is why H ion will predominate over the sodium ion in the race, in the competition, and it is deposited at the cathode, but not sodium ion, because of it is the aqueous medium. You have to compare the reduction potential values. See here, actually what happens, H positive, AQ, that means if I take 2 times to balance this, reduction takes place, I have already told you, then H2 gas. Alright? At anode, out of chloride ion and OH ion, see, you remember the oxidation potential values, always you keep in mind. So you remember it, oxidation potential in decreasing order. In the decreasing order of the oxidation potential, iodide is at the top, bromide, chloride, fluoride, OH negative, sulfate negative, and finally nitrate ion. So tell me, you see this parameter? It will be very helpful in solving questions from the exercise. There, out of chloride and OH, which has more oxidation potential, obviously chloride has more oxidation potential. So take Q chloride. There you have taken reduction potential, but at anode you have to take oxidation potential. So at anode, what will happen here? This is the chlorine negative. Take 2 particles of the chloride ion. Then it forms, you see, oxidation. Cl2 gas liberated, and 2 electrons are lost. What is this? Oxidation. So in aqueous medium, you have to compare the reduction potential as well as oxidation potential. Can you solve question from exercise question from the electrochemistry? Okay, write down. See, write the process of electrolysis of copper sulfate in presence of, you see, platinum electrode. Or if question will consider the process of electrolysis in copper electrode, then your answer is going to change, because it is an inert electrode. Platinum, iridium are the inert electrode. Only its role is to maintain the inflow and outflow of the electrons. The purpose of platinum electrode is that. See here, copper 2 positive, AQ, sulfate 2 negative AQ. It's alright. Since aqueous medium, you take water in the liquid state, but here aqueous form OH negative. Now tell me, it is at cathode and that is at anode. What will happen now? Dear students, see, at cathode, copper ion will attach, and there is a race, there is a competition. So reduction potential of copper ion is how much here? Anybody? 0.344 volt in positive, and hydrogen ion is how much here? 0.00 volt. So copper ion will be deposited because it has more reduction potential value. You go through the electrochemical series, which I have already explained in previous class. So there, at cathode, copper 2 aqueous plus 2 electron reduction, copper in the solid state. Tell me, anybody, at anode what will happen? I am giving you the sequence of the oxidation potential in decreasing order. Out of sulfate and OH, OH will come before the sulfate. Therefore, OH will dominate over the sulfate ion. As such, see, OH negative, to make it balance, here OH plus 1 electron lost, it is oxidation. So OH 4 times, you can take 2H2O plus what is that? O2 gas integrated. So this is the process of electrolysis of aqueous solution of copper sulfate in presence of the platinum electrode. Now I can change the question and I can say process of electrolysis of copper sulfate in copper electrode. Then everything will remain same. But what you change here? What you change? See, copper is attackable electrode, and here is again the copper. So we don't have any problem. So again the answer is same. Copper 2 positive plus 2 electron, copper solid. It's all right. But what about at anode? What about at anode? Sulfate ion and OH ion. Now these two are, suppressed due to the active electrode. We have provided the copper. Therefore, these two will not take part in process of electrolysis. Now, once you take anode, oxidation takes place. Copper is the solid state here, so it will lose 2 positive in the aqueous, and then it is, what is this? 2 electron lost. It is the oxidation. So the difference is, at cathode, solid form of copper is deposited, but at anode, aqueous form of copper ion is deposited. Is it clear to you? So, if I change the next question here, write the process of electrolysis of aqueous solution of silver nitrate. This question is very much given in the exercise of textbook. Ag positive, aqueous plus nitrate ion negative, aqueous. So dear students, since it is the aqueous medium, water is taken. H positive, AQ plus OH negative, AQ. It is deposited at cathode and that is at anode. Now tell me, silver ion and hydrogen ion. What is the value of the silver ion? Positive 0.80 volt, but H is the 0 because it is the SHE, standard hydrogen electrode. That is why we take silver will be competing over the hydrogen ion. So at cathode, Ag positive AQ plus 1 electron, Ag solid. It is a part of, what is that? Reduction. At anode, this reaction going to take place in presence of platinum electrode. I am missing that catalyst, platinum. You applied platinum this time. Then nitrate and OH ion. OH has more oxidation potential than the nitrate ion. You remember it? So therefore, at anode, OH negative, So OH plus 1 electron lost, it is oxidation, balancing it, 2H2O plus, what is that? O2. It's alright, O2 gas is evolved at anode and silver metal is deposited at cathode. But once I will change the question right now, and if I take here silver electrode, then what is your answer? Situation will remain same, but here at cathode it is the silver and that is the silver, so no problem. Again your answer is same, Ag positive plus 1 electron, Ag solid. It's all right, reduction takes place. Dear students, at anode silver is attackable electrode because of silver nitrate adding silver electrode. Therefore these two will be suppressed, or these two will not going to take part in the process of electrolysis, only the silver. So at anode oxidation takes place. Okay, Ag solid, that gives Ag positive A cube plus 1 electron lost, that is called as oxidation. So I can give you the homework. Write the process of electrolysis of dilute sulfuric acid solution. This is all about the electrolysis. Now in my coming class I will explain the very important law based on the process of electrolysis. It is Michael Faraday who gave two laws, Faraday's first law and second law of electrolysis. And many more numericals are given in your textbook based on Faraday's law of electrolysis. Okay dear students, in my next class I will take Faraday's law of electrolysis.